We're going to start recording now. So we have practice lab 1, that's the file, and you have then in your actual canvas in the module for today, module 6, you have a code to download, which is STAT1021 practice lab 1 completed. That's completed because you don't need to program with me, you just need to run the code. So it's really as simple. So please download both files in your respective module 6 folders in your folder for this class, and then open RStudio. And RStudio is presenting, if you just open it without any code loaded, it will look like this, where the cursor blinks and it shows you this greater sign. It basically indicates that this is the console, and it also says on the left top, it says R. So that's the console. That's the core piece of RStudio, and that's basically, that's running all analysis. You have on the right upper quadrant, you have the so-called environment, left, right lower quadrant, you have the plots. Pay attention that there are different tabs. In case you want to explore the other tabs, you can click on all of these tabs. But what we are basically working with is the environment, and down here it's plots. That's all that's needed for this class. Good. In RStudio, we're going on File, Open File, and then we're going in the respective folder. So I have my folder on desktop, which is just, it's a bad habit, but it's a habit I have. I put everything on the desktop. I put it in folder structures in the desktop. I go on In Class. Then I go on STAT1021, I click on module 6, and that's where the respective code is. So I double click completed, and I have here the code in front of me. So this is what you should be seeing if you opened the code correctly. This code essentially is a code with 73 lines. We have in this code, the 2 first lines. Basically, the first comment is a commented comment. It's commented out. It's hashtagged. Hashtag in R means don't run this line. It's just a comment. It's nothing else. So we'll never run this line. What it will run is everything that is black. So everything that's green is commented out. That's hashtagged. And that's kind of common. It's the same in SAS and SPSS. The second line is the RM, that's an actual function, and this is black. You will see this black. So if you go on line 2, so line 1 we can ignore, it wouldn't run it anyways. It would automatically jump to line 2 and run that, and you're running with Control and Enter, or Control and Return. So line 2 was RM, list equals ls. Basically, it just says remove whatever's inside in the parentheses, and list equals ls is basically everything in the environment. The details, I spare you the details why this is written that way, but it's basically, this is in an universal code that will just basically wipe your environment clean of everything contained in it. Yes, please.
My art crashed and it's making me re-download it.
Oh no. Your R or your RStudio?
My RStudio, it just crashed, and it said it's going to take like half an hour to re-download.
That's a problem. Well, you have the recording, so you can reproduce it simply at home. You have the code, you have the recording. Just go along, load it and download it in the background.
Okay.
And reinstall it. Do you have the installation file still on your?
No, that's deleted.
That was deleted. Okay, yeah, then you need to download it again, but that takes half an hour. That should be quick.
It's fine. I'll do it later.
Okay. Yes, please.
R works on my computer, but RStudio doesn't.
Okay, but we need to look at this after class then. Okay, so line 2 basically wipes everything out of the environment. If we go on line 6, if you run line 6, it will create an object for you. That object is labeled DFM2. This is the data frame for module 2. So I'm turning off the light now. And I hope, is anybody still working on the quiz? Is that okay with the, okay, doesn't seem like it. So line 6 builds DFM2. It basically does that with a title for the object, which is here in front of the smaller sign and the hyphen. And the smaller sign and the hyphen basically indicates that everything after the hyphen will be packed into this object. And data frame, you're telling R, I want a data frame, and this will contain that thing in quotation marks, that thing in quotation marks, and this thing in quotation marks. And everything after that is with an equal sign. You basically tell it, okay, so these are the numbers. That's what I want you to put into that particular variable. So you're building a data frame with line 6. And it's not a very elegant way to do that, but it's the way I chose to make it a standalone code. The beauty of this code, as it stands right now, it's a standalone code. You can use this code on whatever R. You don't need any other files. You don't need to import anything. In the beginning, I had it was like import code. Like your colleagues did not like that, and that's why I chose to transition over to a standalone code, which basically does it by itself, and you just gotta run it. So made it a little easier and made it more fun. So you go on line 7. Line 7 is basically saying nothing else. Okay, so I want to look at DFM2. Yes.
How do you run some of them at a time?
Control Enter. At the same time. So first Control, then Enter.
Because they ran the whole code. So.
Oh, that's okay. Now, if you just run one line, you just go in the line. You can also select whatever you want to run. So if you have here, if you just want to run DFM2, you can utilize that code for the next line. It's the same thing. Whatever you select will be ran. If you just go in without selection, we run the entire line.
Yeah.
So DFM2 is basically just showing you then DFM2 is basically just showing you the data. Alternatively, you can also look at the data here on the right in the environment. You have here DFM2, which is 24 observation over 3 variables. You have here on the right, you have kind of a table symbol. If you click on that, it will open the table. So you can look at it just in the same format as you have it in Excel. So that's simple, right? So if you go then further and you have line 8, so line 8 gets a little bit more interesting, because if you look at M2, has 3 different components. It has ID, congruent, and incongruent. So these are 3 columns or 3 variables. And these 3 variables, you can each of them call individually. You can say, okay, so DFM2 gives me the entire object. DFM2 $congruent, with the dollar sign, you tell, okay, so I want DFM2, but I only take a fraction of that. And that fraction I want to see is the variable congruent. So if I do line 8, it will only extract and show me DFM2 congruent. If I do the same with incongruent, it only gives me the incongruent. Easy, right? If I want to do now any operation with this variable, and I say, okay, so DFM2, I want to know now how many entries, how many valid entries do I have for M2 congruent? I can do this with the function length. Because if I'm running length DFM2 congruent, I just get the number of observations, which we know is 24, and R confirms that. Is now in this context not, yeah, it's a no-brainer because we're seeing it on the right? But in some certain situations, you want to, for example, know how many missing entries do I have? You remember how we do in Excel the count? So length is basically the count in R, because you can then specify it, only give me those entries that actually have a value. And if I do that, I actually get those with valid entries, which may be different from that statement, because this also counts the empty cells. I can do the same with incongruent, gives me 24, or I can do it with the dim command, the dim function, which is dimension, gives me 24 over 3 variables. So it's simple, right? Where then really the beauty comes into play is when I want to employ logical criteria. So here I'm saying, okay, so I have DFM2 congruent, I know that's 24. And now I want to restrict it to only those who are congruent is actually greater than 15. You remember we did that in Excel, right? So we had the 15 and we would count out those that were greater than 15. This is how you do it in R. And you basically, you get here a list of those that are greater than 15. So R will automatically extract it for you. That's how you operate variables. So now with 24 observations, it's actually not that complicated to find out those that are 15. Now imagine the same operation with 24,000. So it makes it easier for you to extract pertinent information that you want to deal with on some analytical operation or on some analytical capacity. You want to deal with that in a certain way or form. R will allow that to you quite easily. Yes.
If you just put something right out to get it to extract like what would just appear right now?
Yeah.
What do you do next?
So you're running this function.
Yeah.
You're running dfm2 congruent, which if I wouldn't show that, it would show me all congruents. And now I'm extending this with here the bracket, and I say here dfm2 congruent greater than 15. So I'm specifying criteria which I want to employ to basically extract from M2 congruent. So I get the entire list, and you're saying in the second part of it, in the bracket, you say like, only give me those from that list. And you can do the same with line 16. There's a little typo, please change that. So basically it says here congruent and incongruent in the bracket. Please replace congruent with incongruent, because that was a mistake from my end. Also do the same in line 18, and also overwrite that congruent with incongruent. So it always, it needs to align, otherwise it means something else, right? So that's a little confusing. That was a mistake from my side. Okay, so we have now line 15 gives me all the congruents that are greater than 15. Line 16 gives me all incongruents that are greater than 15, which are more, because we remember incongruent is like the tougher one, right? So if we have line 17, we get the lengths of those that are greater than 15, and these are 9, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's 9, right? So length of incongruence greater than 15 is 24, which is all 24 entries were greater than 15. So that's how you count. That's how you count those cells that fit the criteria. So when we did the Stroop test, we talked about soft coding and hard coding. And that's what we did above, was hard coding. And I think I've mentioned, I don't like hard coding. Hard coding is not good. So that's why we're now learning how to soft code. And it's as simple as it sounds. We have here in line 20, we have written threshold equals, so smaller hyphen, it's the same as equal, 12. And that will create an object that creates a variable that only contains one number, and that number is 12. So once we have this one number, we can now replace our hard-coded number, our hard-coded criterion 15 over there. We can replace this with threshold, and we say, okay, so now we want only those that are greater than 12. So it's you're taking a variable, you're assigning a value to a variable, and then you query it from the variable. It's same principle. If we make this 15, as we had before, same story, then it's the same 9 entries again. So that's, you're just replacing that number basically with a variable, and that variable you can then change however you want. The beauty of that is if you have 1500 lines of code and you're doing that on line 1, and you want to change the criteria for all your code, you're doing that on line 1 once, and then you can do this for your entire code and your entire analysis of your 3 years of work on 1500 lines of code, right? So it makes sense that you would do that rather than hard code it in your code. May not be as obvious now, but trust me, those of you that go into coding, remember it, please. Good. Line 22, we need to do again a little change. Congruent and incongruent needs to be aligned. So we're changing congruent on line 22 and congruent on line 24. But it's the same principle. We do again line 22, takes again the 15 and shows again the same 24 entries. It's 9 and 24. So it does the same operation, but it uses threshold rather than the number. Yes, please.
If we like accidentally did the wrong thing, is there a way to delete it on the console?
I wouldn't know. You cannot delete on the console, but you can rerun it in our studio and the script.
Change everything now.
Exactly. So that script, you need to look at this as a chronology of events. So there's basically a chain of events that is basically happening down the road. And that's the beauty of it. If you quote unquote screw something up, you just go back to the beginning, you run the whole thing again, and it's back to where it was. That's really nice because in Excel you delete something, I don't know, on spot 23,000 all the way down. This is deleted for eternity. And in R that doesn't happen because you're overriding it. You have trace, you can trace every step back because you have it in your code, and you can basically rerun it and restore it. And that's really unbeatable. That is super, super amazing to do. Yes, please.
Is there a point in running it one at a time as opposed to running the whole thing together?
Yes, it has a didactic value because I can explain every line to you.
But like,
in the end of the,
like you would never run it line by line.
it depends. It depends because sometimes if you're dealing with files that are very, very large, there are steps that will take a very long time. So if you're loading in a file, if you're loading a file, so my analyst is running a code right now that's running since last year and last week on Wednesday. So if you have a line like that in your code, you want to have this line separate and not run it accidentally because then basically, yeah. So there's a lot of stuff involved in between. And you need to be very conscious about which line you run and how. And you basically, what you run in the end of the day, you run little fragments of what you essentially need. That's also where the commenting is becoming, again, very super important, right? So yeah, but excellent question, thanks. But yeah, this code is meant to be run as a whole, and this is what we will do in the end. We basically will control A, and we're just running the whole thing through. So that's what we will do. For small codes, that's perfectly fine. Good, so that was congruent, incongruent. That was my spiel about that. And now we have 27, 28, 29. If we run 27, we get the mean and we remember the mean, right? So we remember from our Excel examples that there was like 14 seconds for congruent, 22 seconds for incongruent. And now we're going a step further because all these results, all these functions can actually be packed in arithmetic operations. So if you want to have the difference between the mean of congruent and the mean of incongruent, you just do mean 1 minus mean 2. And that's the difference. Separate, right? So you can pack everything, and R is so super intuitive. You can tell word by word R what to do, and it will do it for you. So that was congruent, incongruent. That was our Stroop test. And that's just all I wanted you to play along and play around with it. So if you're interested in it, then really take your time. Try to understand. You can do nothing wrong with that. The practice lab, you should be able to submit it by the end of this class. And so that 10 points are secured. But take your time, look at it. Maybe it starts to interest you. I'm just putting this out there, like maybe I inspire your interest, right? It's coding. So yeah, so I've started coding very early in my life, and it's if you like it, if it really inspires you, you will love it, and it can be a lot of fun actually. I'm not coding that much anymore, but when I will do it, I like it. So okay, so this is now next is the volcano data set. This is the excuse me.
My whole thing deleted.
Your whole thing. What is the whole thing?
Like it just doesn't look like that anymore. Like the whole thing.
It's being the script.
Yeah, the entire script is gone.
Okay, press Control and C like zebra.
For what?
Or Command and C like zebra. C like zebra.
Oh,
Sue, zebra.
oh, nothing happened.
Nothing happened. Then you need to go back on File, Open File, and just load it again.
File?
Yes, File.
For the threshold, that was 12 before. Should I change it to 15?
If you wish to do so, please.
Yeah.
So that's what I'm saying. Is like play around with it. You can't do nothing wrong. You have the source code, and you have this code really at your disposition. Play around with it. Reproduce the examples. I don't know. Google things you can do with R. It's like it's. I'm referring to it as a sandbox. It's like I'm providing you a sandbox and do with it what you want to do with it. If you like it, my objective is achieved. Okay, line 33 to 34 is DFM3. This is our volcanoes. These are the 55 countries with the respective number of volcanoes contained. If you again open the table, you see again this volcano and country list that we have done in module 3. The objective of this is now to build a frequency table, as we have done in module 3 with Excel. That's a little bit trickier. And therefore, I ask you, please mark line 36 to 43 and run the whole thing. Reason for that is it creates automatically a frequency table, which you see here. And this frequency table basically looks like the frequency table we built in Excel. Why is it hard to explain? Because it's using something that is called an iterative loop. An iterative process is something that you do repeatedly, but with some minor changes that basically gets you to a different result. Essentially, what this code does, it assigns from 1 to 17 numbers to I, and it goes 17 times through, basically going from spot 1 to spot 17, and it uses the length function to count those where this I is basically contained in the volcano count. I'm not going into details what this is and why it does that, because it's beyond the scope of this class. It's even beyond the scope of this class to actually run it. But I have faith in you. You know how to run it. And those of you that are interested, that's an iterative loop. That is, a for loop is in computer science is going to be one of the first things that you will do, likely. Yes, please, Ru. Okay, did you run line 36 to 43? Did you run 33 to 34? Do you have DFM3 contained in your environment? Then we need to look at it after. Try to select 33 to 43 and run all 10 lines at the same time. That should usually resolve the problem. Okay, so this is basically the frequency table. You have the frequency table now contained in your environment. And you can now go through the frequency table. You can look at the volcano counts, and it looks the same as we did it in Excel. And that was our third module. I'm not going to go into more detail. Obviously, you can do much more iterations, much more playing around now. But this is at this point what we need. Then we have next, we have our module 4. In module 4, we dealt with a scatter plot. Module 4 was the visual displays of data. Module 4 was athletic performance as the dependent variable on the y-axis as a function of hours of exercise and practice on the x-axis as the independent variable. So now we're running 47 to 49, control and enter. Gets us these 21 observations. These are our 21 students that did a varying degree of exercise. Athletic performance is stated in the second column. What we're doing now in line 53 is now we're building the very same scatter plot that we did in Excel. And that is, to be honest, and I do like R a lot. I personally think they make much prettier graphs than Excel. You may disagree with me there, but I like those graphs more. So that's a scatter plot in R You can also fit a line through that. That's a little bit more complicated, but those of you that are interested, I can show you at one point how to do that. By the way, I make this point again. Those of you that are interested to learn more R, I happily put together a schedule with you a time where we can do a breakout session. If there's some, maybe from the earlier class, maybe we can do like a little extracurricular R session, like virtually via Zoom. Happily do that. I love R, I love programming. It's always fun. So let me know if there's interest. Okay, so if we run, yeah, so that was the athletic performance story. There was the scatter plot. Then we have module 5, and module 5 was our charity navigator score. So remember the charity navigator score, this was the credibility of charities. So if we select now DFM5, we basically have all our 48 charities here. And that was the data set where we determined like medians and means and interquartile ranges and whatsoever. And we're doing this now in R. Oops. What happens if you have too much stuff open? So we have now our 40 charities here. If you run 57 to 60, that will basically create this data frame. And the first thing you want to do whenever you want to look at data, you want to run a histogram. This is line 62. We basically allow for you to run a histogram. And again, there are no bias from my end, but it's just a much prettier graph than in Excel. So, but that is a histogram in R. And it's a very simple code. It's just hist, and then you basically you give it the respective continuous variable that you're interested in to display the distribution, the frequency distribution of. You can modify it by including breaks. So if you want more breaks, that's basically the breaks is like these thresholds between those bins that define the bins. If you say breaks equals 10, it gives you 10 different bins. So if we're changing this now and we're looking at this a bit more, I will show you. Too convincing. Bins. Bins are the intervals. We can also do more. Yeah. So if you do bins equals 20, breaks equals 20, you get a more granular distribution. So the more you want to characterize your data, these breaks and the number of bins actually will give you additional insight of how your data actually distributes. That's also by aggregating and categorizing data in like larger bins, you're losing information. You're losing a lot of information, and there are actually strong opinions to always have like the most granular data possible. And there are actually advices against categorizing too much. There almost needs to be an indication and a reason why you categorize. And I'll spare you the details why you would do that, but there are, you need to have a reason. Otherwise, always use the raw data. Good. So that was histogram. And now we want to know descriptive statistics. We want to have some numerical insights, right? So this is done with summary. So summary is actually a very simple code, an Intel R base command that basically gives you a minimal entry, a maximal entry, a first quartile, a third quartile. Remember, 25th percentile, 75th percentile gives you median and a mean. And just like in last class, mean and median is somewhat comparable. That means it's a somewhat normal distribution, which, based on our distribution histogram, not necessarily what one would have expected, but the shape of a frequency polygon would somewhat resemble a normal distribution based on the density of the respective entries. And mean and median kind of support this. So now, what you also want to do, sometimes you need, for some certain reasons, you need, to quantify the quantiles. And quantiles is basically you're characterizing the percentile, right? So if you want to have 25th percentile, you just need to write quantile, your respective continuous variable, and your actual proportion that you have to. So if you say 25, you basically get the 25th percentile. If you say 39, you get the 39th percentile. So that's very useful, right? So that can be very, very helpful in many cases. If you do quantile 0.75, you get 75th percentile. You get the same result if you have summary. So here you see summary, and you remember how you can address little things within your data frame, within your variable. You can do the same with that. You can hypothetically, you can put summary even in an object. And let's try this quick. When we say summary is now summary, you basically get summary packed on summary M5. If you pack summary M5 and you call summary M5, it basically saved summary M5. So you packed now that summary of that particular variable into your summary. So you just took something, you ran a function on it, and you packed the whole thing into your object. So now you have that in object. You can do with it whatever you want to do. So if you do now summary, summary M5, and you're interested in getting out the mean, that would be 1, 2, 3, 4. Summary bracket 4 gets you the mean out. So you can address each respective subpart of what you packed into that object with the bracket. That's very elegant. So you can look at it manually, what's inside my summary. If I want to know that, oh, let's do that. Sorry, I thought it would. Yeah, so summary M5, you basically can call each individual entry manually. You can also do 7, that becomes your min, 6 becomes your min or your max. So you can address these things individually, but for now, let's delete that. So we have summary 5 will be the third quartile, summary 2 is the first quartile. So that's 75th and 25th percentile. And if I want to use this now to calculate the interquartile range, let's remember, interquartile range is 25th percentile to 75th percentile. If I want to actually quantify in numeric terms, what is my interquartile range for that data, I would need to calculate 75th percentile minus 25th percentile. And this is again exactly what we're doing here. We're saying S numeric. That's just taking out that percentage header. Summary DMF5 score 5 minus summary DF M5 score 2 gives us the interquartile range. And that's 6.3 for our data. And that's consistent, if you remember, that's consistent with our Excel calculations and basically just allowed for us to run it in R. So that's in broad strokes, the practice lab. Quick addition maybe, since we have more time. But Alex, I was really running short now. 40 minutes left, that's nice. So if I were to do that plot, so also when you ran a plot and you ran 2 plots in series, as you will do at the end of the day, you can go with this arrow here. You can go forward, backwards. You can go back to other plots that you computed, and you can have those plots again. What you also can do, which is quite elegant, you can click with Control or right-click. You can save this image. You can actually save it, and you can save it somewhere in your folder. And you can just add this somewhere in practice labs, practice lab 1. So that's our scatter plot. Scatterplot.png. Now you can save it there. You can also just copy it. You can open a Word document And you can just copy it in the Word document, hypothetically. Why didn't it do that? Copy image. No, just do that. That's good. Okay, so you first need to save it in a folder, apparently. That's that would work. And you take the scatter plot, you basically enter it into your Word document. So now you have, so that's how you would write papers. That's how you would write your thesis or whatsoever. You basically, you compute the graph and you copy it in a Word document. So that's how you would do that. So you have your actual file and you just embed it in your Word document. Now you can write a caption, you like figure 1, scatter plot, and you're explaining it. So that's how you would write a paper. Good. You can do also, well, you can do a million things with these plots. You could hypothetically, you could export it as a PDF. You could automatically mail it. You could hypothetically, you could collect data and you could have R mail yourself a copy every day at the same time. You can do stuff like that. You can do really amazing things with it. Okay. What else? Yes. So we wanted to do, that's a little trickier. Well, doesn't matter. We can do, for example, also a fit line, a line of best fit. This is done with a command called appline. Appline basically creates a line for you. And that's what it does. Appline creates a line in every shape or form. So if you say appline v equals 3000, it makes a vertical line. Oops. Look at this. Okay. So appline will create a vertical line if you add v to it. V like Victor. If we go on Zoom, we basically can look now at our plot. So now we have a vertical line at v equals 3000. So vertical line at 3000 on the x-axis. If we want to do, this a dashed line, we do LTY equals 2. Now we can do this and this. Now we have a dashed line. Just let me. So now we have a dashed line. So that's how simple it is. Right? It's basically like clicking on it and changing it in Excel. It's simple. And if you have a clear vision how you want your line to look like, you can do this all automatically. You can have a function, my favorite plot, and you pull that function in, you program your own function somewhere, you put it somewhere on a separate drive, and you just tell R is like, hey, go to my function, pull in my function, and run that plot. So you can facilitate things a lot. You can do the same thing if you, for example, you do H for horizontal. So we need to change a little bit. So now we do a horizontal line. No, again, doesn't come. So these are like the things that you can do in R. So now we have a horizontal line. If you want to do now a line that is the best fit, and now it's getting a little trickier because you need to do appline, and you need to define that best fit. That's a little trickier because that requires a linear model. And I don't want to explain now what it is because that's a little tricky. But basically, it's you use a linear model for DFM4 athletic performance and DFM4 hours. And you need for that, you need the tilde. The DFM4 hours. And that is your line of best fit. Oops. So now we have a line of best fit. Again, let's do it. So that's now the line of best fit. So you fit that through within milliseconds. And you can, as soon as you add something to the data, you change the data, you run the same code, R does it all automatically updating everything for you. This is like, it's a process of milliseconds. Okay, we want the dashed line, but so same thing, LTY equals 2. We may also want to change the how the points look like. PCH equals 3, because I think that was the triangles, right? No. So that's how you change the appearance of your graph. It was not the triangles, no, it's little pluses. Okay, so you can change the appearance of your code as you want. You can make the points. You can make the points red, like color equals dark red, and that's just me playing around. So now you have dark red points rather than black pluses. Now you have dark red pluses. So it's yeah. So R really has a very nice graphical palette, and you can play around with a lot of things there. Okay, but this is this. Okay, 7:13. Let's wrap this up. Any questions with any of this? I know I showed now a lot of stuff, but it's like this is just playing around, right? And this is this playing around that I basically encourage you to do. If you want to dig a little deeper, please feel free. I can give you some resources where you can find all these functions and how to manipulate graphs. So it's a lot of fun. You can do a lot of great things. Good. What I want you to do for practice lab 1, click on your console, press Control, and I'm doing it for the recording. So press, and so you can rewatch the recording to go actually through each of those steps. Press on the console, press Control and L. This will clean the entire console. Everything that has happened down there in the console is gone. Now click on the script, press Command and A for the Windows user, Control and A. Select the whole thing and press Control and Enter. And this will run the entire code from line 1 to line 73. And now lastly, go in the console, go to the period after canvas and select everything. But just pressing the left button, selecting the whole thing, press Command and C like Caesar. Open Spotlight and write text edit. Text edit will open a text editor. Text edit on the Spotlight. Spotlight is a magnifying glass. It's a magnifying glass in the right upper corner of your Mac, of your iOS or OS. If you click here on New Document, you will get a new text document. If you have now copied from your console everything you selected, you press in the text editor Command and V, like Victor. It will basically copy everything into your text file, and that text file you need to now save by going File and Save. You go into your practice lab folder and you save it in your practice lab folder. And you're saving it as STAT1021G hyphen your family name hyphen practice lab 1. And this is your deliverable for practice lab 1. If you can reproduce these steps, you have 10 points. All right, good. Any questions? Couldn't be any simpler, right? Yes.
Wait, what do you label that?
STAT1021G for the course number and code, hyphen family name, hyphen practice lab 1.
And then you submit it to me?
You submit it via Canvas. All right. Yes, please.
All the changes that you made while we were going over it, we should also have those changes or from the original?
Yeah. Well, on the recording, right? Well, like minor changes, like more aesthetically. You don't need to do the blood colors and stuff, but the congruent, incongruent, please change. That was like a regrettable mistake. Okay, then thanks so much. Have a nice evening.